All right, so 6.2 is about inverse relations and functions. So when you're in Algebra 1, you talked about relations and functions, right? And a relation was a function if it was a one-to-one value. Today we're going to talk about the relationship between inverses, okay? And when we look at relations, we're going to be looking at their graphs. And then tomorrow we'll look at some functions and how to write inverse equations. Okay, so the first thing we're going to do is we're going to start by defining an inverse relation. Okay, so today we're going to graph, and we are going to find those inverses and talk about the domain and the range. Okay, so the first thing we want to do is define what is an inverse relation. Okay, what is an inverse relation? Okay, so an inverse relation is a reflection of points across the line y equals x. Okay, so it's a reflection of points across the line y equals x. Okay, the line y equals x is really special with inverse relationships. So it's actually depicted in this picture here. This dashed line is y equals x. And we do call that the line of reflection. So if these are inverses, then they will be reflections over that line. There's another meaning as well. This is equivalent. This is equivalent to switching the x and y values. Okay, this is equivalent to switching the x and y values. Okay, so you may have noticed these two lines are labeled. We're going to highlight them. So this first line here is labeled as f of x. That's function notation. We're used to seeing that. Okay, but now we have a new notation as well. This is called inverse notation. So this here is pronounced f inverse. It's an f with a little -1 that looks like an exponent. Okay, so it's pronounced f inverse. And that is the inverse of f of x. Okay, it's kind of similar to when, do you guys remember in geometry when you'd have to map things, you'd have a and then a prime? You guys remember that symbol? It was like a dash and apostrophe, a to a prime. Okay, so this is just another symbol, another notation here. All right, so this says we're going to verify the definition by labeling a pair of points on this example here. There's really only one thing to label. Can you guys find the only thing that's labeled? What's the only number that's labeled on that? Yeah, you have the 4. Okay, so you have the 4 here, and then you have the 4 here on the x-axis and on the y-axis. Let's look at the f of x. So on f of x, what is that point? How do I write that as a point? 0, 4. Yeah. Okay, and then on the inverse, this point is written as 4, 0. Okay, so it's equivalent to switching those x and y values. Okay, and again, this is your f inverse. That little -1 there means the inverse. Okay, so we are going to graph the relation, and then it tells us to connect the points, so that's what we'll do. and then we're going to graph the inverse and identify the domain and the range. Okay, identify the domain and the range. So if you're graphing the given relation, they give it to you in a table, but normally when we graph these, we graph them as what? As points, right? So what would this point be? What would our points be from the table? The first point. 0 what? 0, 2. Has to be a point, right? It has to be an x and a y. Okay, can you guys write the rest of the points on there? Okay, so then we should have 1, 5, and 5, 6, and 8, 9. And it says we're going to graph the relation and connect the point. So let's go ahead and do that. I went by 1 unit. So we have enough space for that. So 0, 2 would be right here. Then I have 1, 5, 5, 6, and 8, 9. Okay, so when you connect the points, you're going to connect them in order. So 0, 2 is going to connect here to 1, 5. And then that's going to go to 5, 6, and that will go to 8, 9. Okay, now when you are finding the inverse in graphing, we talked about this is equivalent to switching your x and your y values. So that's exactly what we're going to do. When you find the inverse, you are going to switch the x and the y. Okay, so this would be, instead of 0, 2, I just have to switch it. So it'd be 2, 0, 5, 1, 6, 5, 9, 8. Okay, and then once you graph those, we are still going to put in that line of reflection. Okay, anytime we're graphing the inverses, we're going to include the line of reflection. And that line of reflection stays the same every single time. It's just the line y equals x. Okay, so I have 2, 0. I have 5, 1. 6, 5. 9, 8. Okay, and then when you're graphing the line of reflection, just keep in mind you're graphing a linear function. So you start at your y-intercept. What's your y-intercept here? Yeah, you start at 0, 0. And then what do you use to find the next point when you're graphing a linear function? Let's be specific. The slope, right? What's your slope? The number in front of x, which is 1. Yep. So you do your rise over run. You just go up 1 over 1, up 1 over 1. The line y equals x doesn't change at all, right? It's the same equation every time. So it's the line, which we show as a dashed line because it's not part of the relation. Okay, so it's this line y equals x, and we want to label that as our reflection. Okay, and then we are going to do the domain and range of both of those. So when we're thinking about the domain and range, okay, the domain is the set of what? What does the domain relate to? Yeah, it relates to your what? The x values. So it's a set of x values. And the range is the set of y values. Okay, and whenever we were doing those in interval notation, I would remind you that you're always going to have to start at the lowest value, and then it goes to the highest. Okay, so you start at the lowest, x value, and then you go to the highest x value. You start at the lowest y value, and then you go to the highest y value. Okay, so for the relation, our domain, we can put these in fancy brackets. You don't have to. Okay, we're going to write an inequality that represents your domain. Okay, so I graph my domain in purple here. I can either look at my graph or I can look at my points. If I'm looking at my graph, I want to find my lowest x value. So my lowest x value is going to be here, and that correlates to what value on the x-axis. Or you can look at your points. What's the lowest x value you have in all your points? 0. Okay, so we're going to start at 0. And then that's going to be less than or equal to our x value. And then what's our highest x value? Yep. So it's going to be 0 is less than or equal to x, just less than or equal to 8. Okay, based on that, I want you to find the range. And then I want you to do the same thing for the inverse. I'm going to give you a minute to do that, and then we'll talk about it. Okay, so do the range of the relation, and then I want you to look at the domain and range of the inverse. All right, so our range for the relation, what was the lowest y value? So you can either look in your table or at your graph, right? This is the lowest y. That correlates to what on the y-axis? 2. Okay, so it's less than or equal to, and then just double check that you put the y. And then the highest point was where? 9. Okay, and then again, with the inverse, you can either look at the graph or you can look at your points. So when you're looking at the x values, you just have to correlate that to the x. This one happens to be the x-intercept. So the lowest value was 2. What was the highest value? 9. Do you guys like looking at the graph or the points? I like looking at the points usually. Yeah. And then for the range, what was your lowest y value? 0. And the highest one was 8. So yeah, good. I'm glad you guys noticed. So we talked about how the x's and the y's are switched. So if the domain relates to the x values and the range relates to the set of y values, okay, then those are going to flip.
Gift giving update. This is different than your food drive update. Gift giving is happening in our 4 hours.